Okay, I'm gonna re-record this for the third time, but so let's start by understand what is the definition of absolute value. So I'm gonna write down what is definition of absolute value. So definition of absolute value. Okay, so what's the definition of absolute value? Well, definition of absolute value says if I have a function f of x is equal to absolute value of x. And we already know what a graph look like. The graph is probably look like a V shape. And we say, hey, can you write the same function but in terms of piecewise function? Okay, so what we're gonna do is we're gonna use the red and blue marker to see. So what I'm gonna do is I'm gonna write this in piecewise function. So once I understand what the graph will look like, if you look at this graph, this is actually just look like a positive x graph. So that's the x graph. And on this side, it's gonna be a negative x graph. And with a certain type of restriction. So I can write this in terms of piecewise function. So in terms of piecewise function, I'm going to say, okay, well, f of x is equal to, is same thing is it's going to be in terms of piecewise function, it's going to be like this, a brace. And that's going to be positive x when x is greater than 0, greater equal to 0, and negative x when x is less than 0. Now some people says, do I need to care about this inequality sign? I mean, for me, like it doesn't really matter. I'll just keep one that's greater equal to and one that's less than. So I'm gonna graph it. So what I'm gonna do is I'm gonna graph these functions here. And on the red side, on the left side, I'm gonna use the red marker, and which is negative x, and on this side it's gonna be positive x. So y equal to positive x, and this side is going to be y equal to negative x. Okay, so remember that's just negative of the function, so it's negative f of x pretty much. So, and we're going to talk about that in a second. Now, what happens if I have a function says f of x is equal to, let's say, absolute value x minus 2? Well, first of all, you understand that minus 2 is inside the absolute value sign, so it's moving at the opposite direction as the sign. In this case, this is a horizontal translation because it's inside the absolute value, so it's moving, the function is not moving down, it's actually moving right because it's inside absolute value. If I take the negative 2 outside, then it's moving down because it's outside the absolute value function. So in this case, I can redraw this. I'm going to write in term piecewise function 1 and 2. And this part is going to be blue, and this part is going to be red. So red. Okay. Now this part of the function is blue, so we're going to say that's a function. If I extend this line, it's just going to be x minus 2, which is a positive part of the functions. Like normally with the absolute value function, if that's just going to be x minus 2. On this side, however, is going to be careful. It's easiest way to just put a negative sign in front of it, parenthesis of x minus 2. You can say negative x plus 2, or you can say negative parenthesis x minus 2. I think this is a much easier way to describe. So that's how I would do it in terms of what I do in my tests. So then I say, hey, the piecewise function is going to be written in such a way. So a piecewise function is going to be written like this brace thing. It says x minus 2 when x is greater than 2, or the negative of x minus 2 when x is less than 2. Okay, and this one can choose to one of them is greater or equal to, and that's fine. But if you do realize, just put a parenthesis and put a negative sign in the front, and that becomes this function. And that's going to help me on different cases. So we're going to start by a couple different cases. We're going to start with a simple case. The simple case is just like, okay, well, what is the, so hopefully everybody understand this. I'm going to go to this functions. We say, hey, can you find the limit x approach to, let's say, -3 at maybe x plus 3. So x plus 3 over x plus 3. Okay, and we're going to say from the left side. Okay, so now with this kind of function that if I plug in 3 in this case, that is going to give me 0 over 0. But also it's not helping me solve the problem. Now, for you, that unlike before we have to understand that algebraically maybe we can do this, but the problem is absolute value. You cannot cancel like this because one's absolute value, one is not. But you can probably use the same idea as what we had before. So we can say, well, if use it in terms of, instead of this, I'm going to use it in terms of piecewise function. And using that perspective, that's going to be help me solve the problem a lot easier. So it's -3 from the left side. So we're going to pay attention to that. So what we're going to do is we're going to write this function. We'll pretend this is f of x. And we're going to write it in terms of piecewise. So we know when x is on the right side of -3, we're going to use the positive x plus 3. So that's going to be f of x, right? And that's going to be something like this when x plus 3 over x plus 3 when x is greater than -3. That's pretty much, I just use the positive part of this version. And this part is going to be x plus 3 over x plus 3 when x is less than -3. Now, obviously, this one is going to be equal to this one just going to be 1 when x is greater than -3, and this one's going to be cancel. If you cancel this part, it's going to give you -1 when x is less than -3. So if I using -3 from the left side, that means I'm using this function. That means I'm reaching the answer as -1. Okay, so you have to write it in terms of piecewise. So every time you use absolute value, write it in terms of piecewise. The thing's going to be a lot easier. And you're going to say, oh, okay, this is actually not too bad. So we're going to try a much harder problem. The harder problem may be involved with second degree. Now, usually it's not on the AP exam. AP exam was something like this. You have to understand that answer is -1 instead of +1 because most of the people is going to put +1, and that's the wrong answer. So what we're going to do is we're going to erase this part. We're going to try a question that is a little bit harder than this. And we say, okay, we're going to name this question as x squared minus x minus 6 over x minus 3. And we say we're going to put an absolute value on the top. So this one kind of a little bit more difficult, but you have to understand what is x squared minus x minus 6 look like first. So for me, I have to understand that basic information. What's x squared minus x minus 6? Well, we know that x squared is a parabola. And then we know the y-intercept is probably -6. We don't know what the x-intercept is, but we can also factor this to find out the x-intercept. So first of all, I'm going to just look at this absolute value. So let's look at the absolute value of x squared minus x minus 6. But before that, I'm going to look at what does the x squared minus x minus 6 graph look like. So this one here, if I say y equal to this, then we say, okay, well, that just means my y-intercept is that. It's probably that if I plug in 0, it's going to be -6. If I factor this, it's going to be x minus 3 and x plus 2. So that means my x-intercept is going to be very easy. The x-intercept is going to be 1, 2, and this one's going to be 1, 2, 3. So x equal to 3, x equal to -2. That's my y-intercept, x-intercept. And the parabola is facing up. The y-intercept is roughly -6. So it's going to be something like this. Okay, so that's some type of problem. If I were to do absolute value of this, that means, so I'm going to graph on this part. So I'm going to graph on here, so it makes better graph. So here we're going to have -2 and +3 and -6. So -6. And the axis symmetry probably in the middle. So the graph is going to be like this. Okay, so this graph is y equal to x squared minus x minus 6 graph. So it looks like this. Now what's the absolute value of this graph? Well, the absolute value of this graph that makes anything negative becomes positive. That's why I put it on one of those test questions says, well, do you know the absolute value graph this? So basically, that this part here, I'm going to illustrate in terms of graphing. That's going to help you. But anything negative is going to become positive. So that makes, if I says y equal to x squared minus x minus 6, basically this part is going to be the same. Basically this part is going to be the same, which is the red part. And 6 is going to come up here. So 6 come up here, and it's probably something like this. So basically, if I have a function like this, basically the x squared minus x minus 6 is the black part, but the absolute value of this, sorry, let me put an absolute value on this one. So absolute value of part of the graph is going to become the red graph, which is everything else is the same, but this part is going to be exactly opposite. So what I'm going to do is I'm going to use that as the trick. I'm going to use that as a trick, so I'm going to write it in term piecewise function. So how do I write this in term piecewise function? Well, the piecewise function is going to be, this part is going to be original function, which is x squared minus x minus 6. This part is going to be x squared minus x minus 6. But the only part that's middle part here is spiking up. So this part is going to be negative of x squared minus x minus 6. Put a parenthesis around it. Put a parenthesis around it. So that's the only thing that is really, really changed. Okay, so if I were to graph this, this is what it come out to be. So I know my piecewise function is going to be something like this. My piecewise function is going to be 3 piece. I'm going to say there is a 3 piece. I'm going to do it in blue, so which is the original function. The blue is going to be x squared minus x minus 6 when x is greater than 3. And x squared minus x minus 6, x is going to be less than 2. Because this part here is the blue part, which is we just graphed the black part. There's a black and red is overlap, so they are the same functions when x is less than -2, sorry. Now, the middle part of the function, which is this one, the negative changes back to positive. That's going to basically is x squared minus x minus 6. And I'm going to put a parenthesis, and the whole thing is negative. Okay? Now, this is just going to be between x is less than 3 and this is greater than -2. But remember, this is what the graph we're trying to graph. We're trying to graph this, not the absolute value of this. So therefore, we're going to say that's all over a function of x minus 3. So this one is graph over x minus 3. And this is all over x minus 3. And this is all over x minus 3. Okay, so if that's all over x minus 3, then now to factor this. If I factor this, it's going to be what? Well, it's factor of absolute value x minus 3, parenthesis of x plus 2, right? All over x minus 3. So that means I can factor that. I'm going to change it so that it's going to cancel out. So x minus 3 will cancel out, left with the x minus x plus 2 when x is greater than 3, x plus 2 when x is less than negative 2. Now the middle part here is going to be negative of x plus 2. Okay, because the x minus 3 is going to cancel out, left with the minus x plus 2. So that's going to be x is going to be between negative 2 and 3. Okay, so what kind of question I can ask you? I can ask you what happened when limits x approach to, let's say, 3 from the left side. So x approach to 3 from the left side of this function. So we're going to call it absolute value x squared minus x minus 6 over x minus 3. So if that's the case, then you have to say, well, if I pick from 3 from the left side, do I pick this function? No, this is 3 from the positive side. This is 3 from the left side, so that's the function I will pick. So 3 from the left side, that would pick, result is going to be the same thing as limit x approach to 3 from the left side, and then that's going to be negative of x plus 2. And the result is equal to 3 plus 2 is 5, but times negative, so the answer is negative 5. Okay, so if I were to graph this function, if I say limit x approach to 3 from the left side of this function, that's going to be answer is negative 3, because I don't use this function nor this function. I use the middle function, because from the 3 from the left side, this is the best candidate. This is the best function to go to. If I were to use limit, if I do the same thing, I say limit x approach to negative 2 from the left side, then I would use this function. So x squared minus x minus 6 absolute value over x minus 3. Then I would use the functions of x approach to negative 2 from the left side of x. This one is going to simplify down to x plus 2. So it's going to be equal to 0. Negative 2 plus 2 is equal to 0. So the question of this one is much harder. It had a different perspective. And you guys should look at how to look at this in terms of piecewise, separate to pieces, analyze which one to use, then plug in the limit into the correct one instead of opposed to the wrong one. Okay, that should be a very difficult question for anybody to understand. But if you understand this, you're doing a good job, because this is a beyond AP calculus.